Hi students, this is Mr. Yao. Today we're going to talk about 2.3, where we will learn something called compound inequality. So what does the word compound mean? It means to mix things together. And we have practiced solving inequalities one at a time before. For the next few lessons, we are just going to be working with more complicated questions that involves more than one inequality, or in other words, compound inequality. A compound inequality is an inequality that is formed by the intersection or union. So these are two very mathematical words that you will learn more in the future when we get to set theories. For now, you just need to know intersection is when we use a conjunction word, and union is when we use a conjunction word, or. Next, intersection. The symbol for intersection is this letter right here. It's actually a Greek symbol, but it's like an upside down letter U, capitalized letter U. So that's how we write it, just like that. When several inequalities are combined by the word and, which means both, the intersection inequality is formed. A lot of the times, this inequality is written in compact form, which is a very specific format. The smaller number on the left and the greater number on the right. Just like how we do a number line, the smaller number like 1, 2, 3, 4, 5, the smaller numbers on the left, the bigger number on the right. So that's basically how compact form would have to look like. Only intersection inequality could be written in compact form. Next week when we actually get to the or, when we get to the union, you will realize it can't. So only intersection, or only when you see the word and, these kind of inequalities could be written in compact form. Now let's have a look at a few examples. Example 1. Before we have been graphing like this, say like we have a line, but since we have more inequalities right now, you actually graph them on top of each other, it's kind of hard to tell. Especially because when you use pencils to graph a lot. So we're going to draw the graph slightly different, but they actually still mean the same thing. So here's 3 and here's 6. Because for both inequalities, they don't have the equal sign, so they're both gonna be donut. They're both gonna be donuts. For the 3, is the arrow is pointing to the right. So we're gonna draw, instead of a line, we're gonna draw the square shape. And x is less than 6, the arrow is pointing to the left. So you can either draw it below or draw it above. Either way. And next, for the x is greater than 3, we need any number that's greater than 3, so it's to the right of 3, that area. And for the x is less than 6, we need anything that is to the left of 6, so I'm shading this area. And since this is a compound inequality and it's an intersection, or and, the keyword is and, I'm going to need the section that's being shaded for both, so the middle part. Hence, that is the only part that's the actual. Now I need to write in compact form. Smaller number, which is 3 on the left, greater number, which is 6 on the right. This middle part, the part that we shaded, is basically our x, because that's our variable and that's what we're solving for. So x still in the middle. And then if you just look at the number line, because the number line gets bigger to the right. So that means 3 and got bigger to x, then got bigger to 6. That means 3 is less than x, which is less than 6. And that is a compact form. So you might be wondering, wait, but I started with x is greater than 3. How come it changed? Well, if you look at it, your x is not on the left anymore for this part of the inequality. Your x is actually on the right. That's why we flip the sign. And my suggestion, just completely ignore the beginning of the question. Just write your compact form from the graph. 3 is less than x, which is less than 6. That's number 1. Number 2, -2 is a solid dot because it has an equal sign. 1 is a solid dot because it also has an equal sign. -2 is pointing to the right, and 1 is pointing to the left. I need the middle part being shaded. Final answer for compact form, -3. Middle is x, so less than or equal to x, or less than or equal to 1. And you can see, if you're wondering, wait, how did I get these signs? Well, if you look at the graph, they're both dots. That means we have to have the equal. Next, -6 on the left, and a -2 on the right. -6 is pointing to the right, -2 is pointing to the left. Middle part is being shaded, compact form. -6 is less than or equal to x in the middle, which is less than -2. That's example 3. Now let's get to some examples that are a little bit more complicated. Example 4. Here are the steps on the left side. Step 1. Separate the two inequalities. And this step may be done for you, and you are going to solve each inequality separately. And in this case, for example 4, well, the two inequalities are separated, so that means we can just solve each individually. At 5 on both sides, 2x is greater than or equal to 8, x is greater or equal to 4. -3 and -4 on both sides, so x is less than or equal to 3. Next, we're going to graph each individually, just like how we did it. X is greater than 4, so 3 is here, solid dot because it has an equal sign. 4 is here, solid dot because it has an equal sign. 3 is actually pointing to the left, and 4 is pointing to the right. And then we are looking for the overlapping part. Overlap is just a different way of saying intersection. And if you look at the graph, there is no intersection. There is no overlapping. So the answer is no solution. That's example 4, which is a special case. Number 5, steps are still on the left side, same thing. We're going to solve each one individually. Divided by 3 on both sides, so -4 is less than or equal to x. And a big reminder, we can't start graphing until the variable is on the left side. Right now it is not, so I need to move the variable to the left side. That means I need to flip the sign. For the other inequality, subtract 2 on both sides. X is less than 2. So at -4, it is a solid dot. At 2, it is a donut. -4 is pointing to the right, and 2 is pointing to the left. Middle part is being shaded. Final answer, -4 is less than or equal to x, which is less than 2. That is number 5. Bit more practice. Number 6, we're going to solve each one individually. Add 1 on both sides. 5n is greater than -25. Divided by 5, n is greater than -5. Add 2 on both sides. 7n is less than or equal to 14. N is less than or equal to 2. So at -5, it's a donut. At 2, it is a solid dot. 2 is pointing to the left. -5 is pointing to the right. We need the middle part. So -5 is less than x, which is less than or equal to 2. That's example 6. Example 7. Well, this looks slightly different. There's no word and, but it actually is very simple. We just need to do the first step to separate the two inequalities. And here's how it goes. I'm going to put it together with the number on the left, put a word and, then I'm going to copy the middle part again and put together this time with the number on the right. And there we go. We have two different inequalities. So for the first one, add 3 on both sides. 2 less than x. Don't forget, you can't graph until your variable is on the left side. So flip them. That is greater than 2. This one, add 3 on both sides. So x is less than or equal to 8. 2 is an open circle. 8 is a solid dot. 2 is pointing to the right. 8 is pointing to the left. So there we go. 2 is less than x, which is less than or equal to 8. That is example 7. Number 8, same thing, separate them. 2 is greater than or equal to 3x minus 8, and 3x minus 8 is greater than -2. You might be wondering, well, couldn't I just add 8 on both sides and divide by 3? Yes, technically for these kind of questions you can, but as when we get to complex inequalities tomorrow, you will realize that will seem more like a shortcut. So let's just be more consistent and just separate them. This one, variable on the left side, less than or equal to, flip the sign. So 3x is less than or equal to 18, x is less than or equal to 6. Add 8 on both sides, so 3x is greater than 6, so x is greater than 2. 2 a donut, 6 a solid point. Here's greater than 2, here's less than 6, less than or equal to 6. We shade the middle part. 2 is less than x, which is less than or equal to 6. That is the final answer for number 8. Number 9. Negative 3 is less than or equal to x over 2 plus 1. And x over 2 plus 1 is less than 2. I can solve for this one. Minus 1 and minus 1. X over 2 is less than 1. So x is less than 2. For this one, subtract 1, subtract 1. Negative 4 is less than or equal to x over 2. I can multiply both sides by the 2. So negative 8 is less than or equal to x. But my x is still on the right side. I need to flip it to the left side before I start graphing. So I need to flip the sign. Negative 8. Negative 8, solid dot. 2, open circle. 2 point to the left. Negative 8, point to the right. Final answer, negative 8 is less than or equal to x, which is less than 2. And that is example 9. That is everything for 2.3. Simple compound inequalities. Thank you.